Hello, everyone. I hope everybody can hear me okay now and see me as well. It's 4 o'clock, so I suggest we start. And if everybody will join us a bit later, so it's not a problem. I'm very happy to see a lot of you joining here and registering for the event. Actually, as we first thought of it, it was supposed to be face-to-face, and then we had to adjust and change that to online. But from the number of attendees and the registration, I see that a webinar is something quite effective nowadays and interesting to a lot of people. So yeah, very happy that you could join us, and hopefully you'll have like very productive and interesting time for the next few hours. A few just logistic details that you can see in the slide. First of all, there is a lab guide that will be following throughout the workshop. So there's a link to it. I also pasted it into the chat, and I'll do that once again after I'll do the intro. So you can just download it and look through how it goes. Also, we have some test accounts ready for you, and if you like to get those, just drop an email to contact@cloudwiser.eu. I saw that we already shared a number of accounts, and I saw a few of the emails in the inbox at the moment. So as soon as I'm finished, I'll send you the links. Don't worry. We have like 10 or 15 minutes before we start using them, as we'll start off with some intro from Aivaras' side with the theory around what Kubernetes is and how it works with the containerization. And last thing, for the Q&A, if you have any questions, they're very welcome. Please go ahead and then don't be shy and then throw them at us. There's a special Q&A section below if you see that in your screen. So we'll do our best to answer them when we have the time slots in the workshop, but if some of them will be left behind, don't worry. In any case, we'll answer all of them and just send the questions and answers in the follow-up email that you'll be receiving. And together with that, we are recording the workshop, so you'll get the link to the recording as well, so you could follow up or share it with your colleagues or use it any way you need to. Before we begin, just let me spend a few minutes to introduce Cloudwiser. We are one of the organizers of this workshop. So we're the advanced tier partner of AWS, and we're focusing purely on the Baltic states. So that means Estonia, Latvia, and Lithuania are the main territories for us to help out current and potential AWS customers. If we would like to, in a nutshell, basically we do three things. So one thing which is meant for the companies that are only thinking about moving to AWS, so that's helping out with the migration, doing a simple lift and shift, or doing some modernization on top of that, which usually involves also things like Kubernetes, containerization, and microservices. For the companies that are using AWS already, we are providing the added value resale services that usually come in different flavors. Usually that involves some cost optimization, consulting audits, and help, or in some cases that's just pure discounts or special pricing. So this is something that we do as an official partner of AWS. And the last but not least, security and networking for inside AWS. That's one of the areas of focus for us, and we're really working a lot on that area. And just to give you some ideas on what are the specifics of that is, for example, we have just been recognized as one of the service delivery partners for AWS WAF. That is Web Application Firewall, and then we're now one of the 4 partners in Europe that AWS has specifically for that service. And like we're even working with some special third-party vendors like Checkpoint to help out to set up their firewalls on AWS and similar stuff. So like if anything like that would be interesting to you, just reach out and give me a note. But today we're here today to talk about containerization. And as mentioned, this is really an important part for us and an area of focus, as usually migration to AWS involves modernization and nowadays, you know, Kubernetes, microservices, all of that stuff is very popular, and we usually do things like that. And we have a very special partner from Lithuania joining us today, that is Bluebridge. They are one of the partners and companies that are involved in many of our projects that are also covering the Kubernetes and EKS or ECS services on AWS. And I'm very happy that we'll be having Aivaras, one of their like top specialists in this area, that he will be delivering the whole workshop, and he has prepared the whole agenda for you. And well, that's, I guess, all for me from my side for the intro. And Aivaras, would you like to take it from here and introduce yourself?
Yeah, hello guys. And now I should share my screen, yeah. Okay. Okay, so yeah, as Julius mentioned, if you want to go hand by hand with me on the workshop, you can ask for accounts. And if you don't, you can just watch and a little bit learn. So about myself, I'm Aivaras Sukackas. I was working for the last 6 years in the Bluebridge, mostly for the last 2 or 3 years for the containerization Kubernetes service on-premise, and also on the AWS with the ECS, with all kind of DevOps stuff that goes around. So basically, if you won't catch us with a workshop, you can always open a lab guide, which we provided, and just go through it, and you can just catch up us. So yeah, as Julius mentioned, you can ask us questions in the Q&A part, and we will answer it right now or maybe a little bit later. So, okay, about whole workshop. So this workshop will be handed by you from the very beginning, from the infrastructure point of view on Kubernetes, with all kind of objects on Kubernetes. And after that, we're gonna have a little bit advanced stuff using Kubernetes. So if you guys having an account, so please join, please log into the AWS console with these kinds of accounts, because after a few minutes, we're gonna basically need them. So if you won't got any account, so you, as I said, you can use it lab guides to follow us on that kind of map. Okay. So let's start on agenda. Sorry. So first of all, what we're gonna do today, we're gonna launch an EKS, which Elastic Kubernetes Services on AWS. Basically, it is managed service for Kubernetes. While our Kubernetes cluster will be deploying, we're gonna have a short introduction to the Kubernetes. As I mentioned, that we're gonna have a theoretical part of the Kubernetes and the AWS EKS, how they implemented their own Kubernetes on the managed service point. After that, when we have our Kubernetes cluster up and running, then we're gonna deploy our Kubernetes Dashboard. What it is, we're gonna see a little bit later. And after that, we're gonna deploy example microservices. So basically, we're gonna start from the predefined images for our example microservice, and we're gonna basically be focused on the Kubernetes itself. So, okay. Next thing, we're gonna auto-scale our applications, and we're gonna expose them to the outside of the wall that we could from our web browsers to just search them. And lastly, from the workshop part, we're gonna have a Helm, which is a Kubernetes package manager, and see how our applications can be packaged inside of Kubernetes and what makes us an additional usage of them, additional efficiency of the Kubernetes applications as is. And last topic, from the theoretical part, we're gonna have some AWS containerization cost topic, where we're gonna discuss about how to save some money on the containerization inside an AWS, and also how to get efficient with it from the point of resources. Okay, so let's start. First of all, what we're gonna do, as I mentioned, we're gonna launch our EKS cluster, and we're gonna launch it by the EKSCTL, which is a command line tool developed by AWS and Vworks. Also, you can do that just by the AWS console, but our EKS tool, because it's a tool that automates much of experience of creating our AWS EKS clusters, it makes us a little bit simpler to us to do that. So, okay, so firstly, let's go to our AWS account that we provided, or if you don't have it, please ask for it, or you can just watch it. So, okay. I am already, are you seeing my AWS account? Yeah, I think everything is fine. Okay, so first thing first, when you connect to your AWS management console, ensure that you are in the island region. If you don't know how to check it, please follow me. There is next to the support, there is a tab where you can click it and you choose an island region, because this workshop, every way through, we're gonna use an island region because we have some predefined environment for us to work with. Okay, next thing, when you are in the island region, we can just start to deploying our EKS cluster, yeah? So for that, we're gonna need a tool that's called Cloud9, so which is a simple cloud ID for writing, running, or debugging code. So it is pretty good for us to work with because we have an ID where we can just edit text, review it, and run it some commands inside the terminal, yeah? So when you open your Cloud9 environment, you should see under your environment that you have EKS workshop environment. So please click on the OpenED. It should take some time because it's based on the simple EC2 instances. So it should take about 20 or 30 seconds to open it, but be patient, everything will be fine. While we're waiting, your Cloud9 environment will open. I can show you what it is, what it has. So in the left corner, we have our folder structure. So basically, we have one folder. It is EKS. So basically, there we're gonna work. We have all prerequisite for that inside of our workshop. In the bottom, we have our text editor window, and in the bottom, we have our just simple Linux terminal. So, okay. So to launch our EKS cluster, first of all, what we're gonna need is some kind of configuration to do that. So firstly, I'm prepared to you an YAML file which define our EKS cluster deployment configuration. So let's go through it shortly. So first of all, what we have here, we have a metadata where we specify our basic information about our EKS cluster. So we have a name for our EKS cluster. We don't need anything to be changed because it works as it is. We have a region where we want to deploy our EKS cluster, our Kubernetes cluster. So it is EUWest1, which is an island. And also we have to specify our managed node groups, which of them we're gonna have just a one managed node group. We'll call it a node group, and it will have a 3 simple instances by the T3A small flavor. So what does it mean? We'll have just simple 3 EC2 instances inside of Amazon. EC2 instances, who doesn't know, it is a simple virtual machine called in the AWS. Also, what we're gonna have deployed automatically by the EKSCTL tool IAM role for the ILB ingress, and we're gonna specify our secrets for the communication inside of the EKS cluster, and it is predefined. You don't need to change anything. So basically, our EKS workshop.yaml works like a configuration file where we specify all the kind of configurations that we want to see inside our EKS cluster. Okay, so let's go to our terminal. And yeah, one more thing. Inside of EKS folder, you have a file called a cheat sheet where you can find all kind of comments which we're gonna using through the workshop. So if you don't want to write any comments inside of a terminal, you just can simply copy it and paste it to the terminal, and that's how it works. So basically, if you want to write, you can write it, or you can just copy it and paste it. Okay, so what we pasted there, we have an EKSCTL that I share with you that it is a command line tool. So we're saying for the EKSCTL tool to create a resource that is called cluster. So we'll be creating a Kubernetes cluster, and we'll specify -f to our EKSCTL tool to take a configuration from specific file, to read the file and take all the configuration, and by these kind of configurations, our EKSCTL tool will create us a Kubernetes cluster. So, okay, so just click it. Okay, I'm already having this kind of cluster, so it is my thing to do, but yeah, I'll just delete it. Basically, because I'm having her, you should see that your EKS cluster, it starts running. You should see that your EKS cluster stack, it is starting to deploy. So it should take about 15 to 20 minutes to deploy. So we can go to the introductions to the Kubernetes and EKS. So let's get back to our slides. Okay, so we'll have introduction to the Kubernetes and EKS. Julius, can you hear us? Can you start the poll or
Sure, just a moment.
So yeah, so first thing first, we want to know, do you using some kind of, do you have experience level with AWS, and also do you have experience with containerization or something else? So
okay,
please vote.
Yeah, I see the answers coming through. Let's just give some time.
I will check. I tried some services and I have basic understanding of this.
You shouldn't be shy. Yeah, we have more than half people already voted. Maybe 10 more seconds, and that should be it. Okay, so I'm ending the poll now, and let's see what we have. Okay. Can you see the results?
Yeah.
Okay. So we have about half of people or that already have some experience with AWS, and 12 people are pros. So
Nice.
they will help us out if we have some problems.
Yeah.
Should I start the next poll as well?
Yeah. We should start the next poll. So
Okay.
while you are answering our questions, so I want to answer the first questions. Are you planning to use Helm 3 or Helm 2? So as you seeing my terminal, we're using Helm version 3.
Okay, I see what's coming in for the experience around containerization and Kubernetes as well.
Okay, so I can answer the second one question because we have already 2 questions. How to determine when it's reasonable to migrate from EKS to ECS? It is a hard question because when you have a big infrastructure and you have a lot of worker nodes going through, and you have different kind of persistence storages, etc. So when you basically have a big infrastructure on the containerization, and you have different kind of approaches to use it, because you need also a Windows machines, also some kind of virtual machines where you need a high performance COPS, or other way you don't need them. So it is quite good to go from ECS to EKS in that kind of manner, because when you have a small clusters, it is okay when you don't have to manage big kind of instances. And also with the EKS, with the Kubernetes, it is a little bit simpler to use whole application deployments, even in the separate tasks, in the single tasks, than in the ECS. So basically, that's how you determine it is reasonable, when it's reasonable to migrate from EKS.
Okay, we have the results for the experience, and as I see, most of attendees today are at the beginner or intermediate level. So I think then we should not go very deep into details, but yeah, explain more on the stuff that we're doing.
Yeah, so we can go back to our slides right now, and we'll have a short summary of the short introduction to Kubernetes. So let's keep moving forward. So what is Kubernetes? Kubernetes, it is open source system for automating the deployment, scaling, and management of the containerized application. It was originally designed by the Google and announced in about mid-2014. So its development and design heavily influenced by Google's Borg system, which is a basic management system of the Google. But after some while, Kubernetes was rewritten in the Go, implemented in the Go language, because originally it was developed by the C++. So now Kubernetes is maintained by Cloud Native Computing Foundation. So basically, it has really, really good and big community around them. So basically, Kubernetes, what it does, it helps us, our developers, our DevOps, or even system engineers to run and maintain various containerized applications in the scale with the practice gathered by the Google. A lot of our customers ask why and who are using Kubernetes. So Stack shared with us with some kind of gathered information about it. So there is a top reasons why companies and developers use Kubernetes. They ask for this kind of different companies, why they're using them. So mostly because of it is a leading Docker container management solution. It is simple and powerful, and yet it's open source. So basically, I suggest with these kind of reasons, because yeah, when you learn it, it is simple, but it could be a little bit hard. And basically, about 1 2,800 companies reportedly use Kubernetes in their tech stack. So I think this number should be a bit much more bigger, because a lot of companies really use Kubernetes in their daily basis. Even they haven't used them in the production, but they have in their development environments or similar. So firstly, when I started to use Kubernetes, I tried to know everything in the big chunk. I tried to know everything about Kubernetes from inside. So it was pretty big pain in my head, because my head was like this kind of slide. We have a lot of new things. I don't know how that works from the beginning. I don't know how this kind of objects on Kubernetes works, and etc., etc. So this was a pretty big pain in my head. But after some while, I understood that I should learn it from another perspective of view. So at the first, Kubernetes might appear confusing and really, really messy, because you have a lot of information, a lot of new objects to learn about, but yet there is some order in this chaos. So my suggestion for you guys who never tried and never used a Kubernetes inside of them, inside your organization or even at home, please try to use it with the baby steps, with the simple task that you want to do. For example, start one kind of container from the example, then you can manage to maintain that container, to change it, to use your own container, and etc., etc. So let's start our first baby step and first task to know about Kubernetes infrastructure. Yeah. So basically, Kubernetes cluster consists of the machines that are called nodes. Yeah. Nodes are on the Kubernetes cluster may be physical or the virtual. So there is two types of nodes inside of Kubernetes. There is a master node type and there is a worker node type. So master node type, which makes a control plane, acts as an essential brains of the cluster. So masters are basically responsible for running essential services inside your Kubernetes cluster. Basically, without masters, our Kubernetes cluster just won't work at all. And there's a second type, which is called a worker node type, as I mentioned, which makes us a data plane. So basically, our worker nodes runs the actual containers image via pods. What it's a pod, we're gonna have a short summary a little bit later. So basically, worker nodes are the heavy workers where it does the lifting, where it does store our containerized applications. So let's dive a little bit deeper into how nodes interact with each other and how components are made through those kind of types of nodes. So first of all, we have Kubernetes master nodes, and it consists of 5 basic components inside of it. So first of all, we have a Kube API server where all the clients, all the users, all the other applications that interact with the Kubernetes cluster strictly goes through the API server. So basically, API server acts as our gatekeeper to the cluster. Next thing, we have a etcd, which is a consistent and highly available key value store used as Kubernetes backing store for all the cluster data. So basically, everything we do in the Kubernetes cluster, every state, every configuration, everything around Kubernetes information, it is stored in the etcd. Next one, we have a Kube controller manager. So controller manager monitors the cluster state via API server. Yeah, because everything inside of Kubernetes works through the API and outside, and steers our cluster towards the desired state. So yeah, so basically, if our Kube API server it is a gatekeeper, our controller manager does the job or get from the APIs. Also, we have a cloud controller manager. So it's a daemon that provides us cloud-specific kind of knowledge and integration capacity to the Kubernetes. So basically, it is like a bastion host from the Kubernetes to the public cloud providers or something else. So basically, our cloud controller manager allows us to integrate our public cloud providers on the private cloud, if it's Ceph or it is VMware, to use this kind of resources inside of our Kubernetes cluster. Yeah, and we have Kube Scheduler. So basically, Kube Scheduler, when you create your pod, when you create your container, it needs to be stored somewhere. So Kube Scheduler ensures that your pod should be placed in the specific kind of worker node. So it places it says where your pod should be placed in the worker nodes. And you can specify some kind of rules to him, how it should be managed to deploy that kind of container inside of different kind of workers in Excel. And there's also additional service. So this is like features to the Kubernetes. And we can have, for example, kubedns, which provides us a wide cluster-wide DNS service. We have a hipster, which is metric collector. We can have a Kubernetes Dashboard, which we've seen in the first slides, what we're gonna do to deploy them. So basically, it's a general purpose web-based UI for the Kubernetes. So basically, everything around that keeps our life a little bit easier with the Kubernetes and with its management. It is additional services and features. So that's it about master nodes. And what is a Kubernetes worker node? So this kind of our heavy lifters has three kind of components. So first of all, we have a kubelet. So it acts as a node agent responsible for monitoring all, for managing the pod life cycle on its node. So basically, it monitors your pods inside your worker nodes. Pods, it's equal like containers, and manage them. It also a link between your master and the worker. So basically, kubelet, it is a master nodes agent. Next thing, we have a Cto Proxy. So Cto Proxy manages the network rules on each node and performs connection forwarding or load balancing for the Kubernetes cluster service. So basically, it's like a networking component of Kubernetes. And we have our container runtime. So basically, it's container runtime interface, such as Docker or Archity, which allows us to run our containers. So from these three slides, I want to remember that there is two types of nodes. First of all, there is a master node, and second one, it is worker node. Master node works as essential brains to our Kubernetes cluster, and the worker nodes acts as our heavy lifters, where we store basically all our containers inside. And everything inside of Kubernetes goes, every communication inside of Kubernetes goes through the APIs. So we won't discuss or we won't tell how many of worker nodes or master nodes you can deploy, because it varies every time, because it depends from your requirements. You can have 3 master workers and 3 worker nodes for the high availability. You can have all-in-one nodes and master and the worker node for, I don't know, for learning and development, and etc., etc. This is a different kind of stuff. So let's get going and go to the Kubernetes objects. So what kind of objects? So first of all, let's start from the namespace. What is a namespaces? For me, it is like logical isolation between different environments. When you want to separate your kind of environments between one and another. So basically, when you have different kind of departments inside your organization, you you can separate them by the namespace. That's how one department resources won't be interacting with another department's resources. So basically, the best thing to understand this kind of namespaces is through the development and production environments. When you have different kind of environments where you want to store your applications. So for example, you have a namespace for the dev and namespace for the prod. So basically, these dev have their own containers, and the namespace prod will have their own containers. So each of them won't interact with each other if it's not written in the kind of configuration. So basically, namespaces is logical abstraction where you isolate your resources through them. So basically, we have different kind of namespaces, and they are isolated from each other. Next thing, let's talk about a little bit more of the objects and basically what we're gonna do today with these kind of objects. We're gonna interact with them. So we have a smallest and simplest unit in the Kubernetes objects that you create or deploy, which might consist of either a single container or the small number of containers that are tightly coupled and they can share resources between them, and it is called pod. So basically, pod, it is smallest Kubernetes object inside of Kubernetes cluster. Next one, we have a replica set. So replica set ensures that specific number of pods replicas are running at any given time. So if we say that our replica set it is set to the 4, then we'll have 4 identical pods running through our Kubernetes cluster. If we're gonna have our replica set to the 2, then we'll have just the 2 pods running inside our Kubernetes cluster. So, and on the top of that, we'll have a deployment. So basically, deployment controller provides us a declarative update of the pods and the replica sets. So basically, you can store your whole application inside the deployment. Sometimes you want to separate, for example, if you have a front end and a back end, to the different kind of deployments, because when you need to deploy just your backend application, you need to deploy just to scale that kind of backend application, then you need just scale just the backend application, not on the front end. So basically, deployment, it is whole your logical applications stored in the one. Next one, we have a service. So service provides us a method of exposing and consuming layer 4 pod network accessible resources, yeah. And they're using label selectors to map groups and pods and ports to the cluster-wide unique virtual IP. So what I mean by that, that our service inside of Kubernetes acts like a simple load balancer, where you have also source ports, destination port, and you can have a kind of traffic load balancing through your application. And it is basically that. About service, we're gonna have a separate slide to have a little bit deeper understanding how it works. And also we have an ingress. So ingress, its controller, it's the primary method of exposing a cluster service, usually HTTP service, to the outside world. So basically, it is like reverse proxy or the HTTP router, simply like that. If you have a URL and the path, and you need your path to go to the specific kind of service or specific kind of container, then you can have written your ingress rule, which does that, and you can have this kind of same URL, but with a different kind of path, and it will route you to the another kind of service. So basically, that's how it works. So about services. As I mentioned, it is a load balancer, basically. So how it load balance this kind of pods when we have auto scaling or decreasing them. So basically, when we are creating our applications, our pods inside of them, each of the pods has its own labels. So for example, in this slide, we have two different applications. So first of all, first application consists of the 3 pods, and each of them are identical, and each of them has a label called A. And we have a different kind of application which has 2 pods, and they are also identical, and each of them have a label called B. And service, when you define a service, you need to write a label selector. So by that kind of label selector, you define to which kind of pod your traffic should be routed. Also, you define a source port and destination port as in the usual load balancer, but also you need to specify a selector by whom your service will know where your traffic should be routed, to which kind of pod. So that's how our services works like a load balancer. Everything in the service, it works automatically. You don't need, like in the classical load balancer, write your own endpoints, etc., etc. If you define a selector, if you define a source port and destination port, then you can have automatically increased your endpoints and decreased. Also, services through the cluster, they are used to expose our applications. And also you can expose them to outside the wall. But for that, we're gonna see a little bit later. One more thing about services, each of the services uses a DNS name through the whole cluster. So if you create a service with the name A, for example, or example A, then you can access this kind of service inside of your cluster through the DNS name, which will be example A. So that's how services work. And yeah, we had our application formation. We have pods, which is our application as is. It is smallest and simplest unit in Kubernetes. We had our replica set, which defines us how many of pods we have. We had a deployment. Also, we have a service review, and we had an ingress review. So basically, without an ingress, everything we're gonna need it today. And last thing about Kubernetes objects, it is how to health check your application. So basically, there is 3 types of health checks inside of Kubernetes. So basically, first is command probe, when you execute some script and should get an answer. If the answer is 0, your pod is okay. That means your pod is okay, but anything but 0, then pod should be restarted. And this kind of restart, it is initiated by the Kubernetes itself. You just need to write some kind of configuration of the health check, for example, command probe, and then ensure that by this kind of rules, your pod health check will be ensured. Also, we have an HTTP probe, which checks our HTTP URL inside the pod, and we have a TCP probe, where we check our TCP port inside the pod. If it's binded, everything okay, and can connect everything okay, but anything else that means that our pod should be restarted and it doesn't work as used. So that's all about Kubernetes objects. About them, there is a lot of more Kubernetes object, but this is the basic what we're gonna use today, and this is a basic or simple steps to perform our workshop. So now let's talk about Kubernetes cluster setup. So one way we've seen that we can deploy our Kubernetes cluster through the command line tools and with the AWS EKS, it is pretty simple. And there is some kind of other ways. So these tools that you see on my slide, I already used. And basically for me, if I want to run my Kubernetes cluster for the development or the learning purposes inside my laptop or the one single, I don't know, just virtual machine, I will use a Minikube because it is greatly developed for that kind of purpose. It will deploy all in one Kubernetes cluster inside just one virtual machine or just one or even your own laptop. And there is a KubeSpray or KubeAdmin if you want to know a little bit deeper how your Kubernetes interacts with when they have a little bit scale, when you have it, for example, 3 kind of worker nodes and 3 kind of master nodes. And there's a commercial options available. So we have an Amazon EKS, which is basically I mostly use, and that's it. So let's see how Amazon implemented Kubernetes itself to them, because all this kind of commercial options available. So for example, Amazon EKS, it has managed service. So what does it mean? That you don't need to manage your Kubernetes master nodes. You need to manage just the worker nodes, and it gives you a plenty of free time because when you're managing on-prem infrastructure and you're managing the Kubernetes inside of your data center, a lot of work comes from the master points of perspective. So let's see how EKS implemented their own architecture. So yeah, what we see here, that we have our EKS control plane and we have our data plane, which is Kubernetes worker nodes. So basically it is the same as you use in the classical infrastructure or the on-prem infrastructure, but all the control plane, it is hidden from us because everything, it is managed by the Google, managed by the AWS. So yeah, and you have to manage just your EC2 worker nodes. So basically that's how they implemented, and when you try to use it once, you never want to go back to the on-prem infrastructure because it's a lot simpler to use an EKS than you use Kubernetes on-prem. Or maybe you are the, I don't know, DevOps god or something else that you automated everything and everything works perfectly inside. So basically from the high level of perspective, how it is done, you have some kind of tool, you connect to the URL API endpoint provided to you, and that kind of API endpoint connects with your workers inside of your VPC. So if you go to your accounts that we provided and you have deployed your EKS cluster, there you should see 3 instances without name, and if you check their security groups, they will be correspond to the that it is a EKS cluster. So basically it is your 3 workers displayed in the different kind of availability zone. So last thing from theoretical part, how to talk to Kubernetes cluster. So first of all, we have YAML. Basically, you have seen it, that we have our yet another markup language by whom we're gonna specify all the configuration, all the new deployments or new configuration to the Kubernetes cluster and its own object. We have our kubectl, which is command line tool, which we're gonna use oftenly today. And we have a graphical interface, which is a dashboard, which we're gonna deploy but won't use it. Dashboard, it is for the Windows like guys who likes not a command line but just a good. And there's also the last thing you can use. It is all dirty way, just using JSON and the API direct calls to the Kubernetes API. So that's all from the theoretical part. I hope you won't tired for this kind of topic. So let's see, do we have any of the questions about?
I see we have a number of questions in the Q&A section. Would you like to go through at least a few of them before we start, or should we go on to get our hands dirty?
Oh, maybe let's get our hands dirty, and we'll answer our Q&A a little bit later. So okay, let's go back to our Cloud9 workshop. So our Cloud9 environment. So all of you guys should see that your cluster, it is deployed. I cannot show you right now because I forgot before the workshop to delete my cluster, but it is not a problem because I tested like 100 times and you should be deployed, really. So first thing first, let's try to use some of our commands of our kubectl commands to ensure that our EKS cluster it is working. Yeah. So for that kind of purpose, we're gonna use a kubectl. It is first our kubectl commands, which you've seen in the previous slide, and we're gonna specify a get command. So if you want inside of Kubernetes, when you're interacting with the Kubernetes cluster, and you want to get some kind of information, short information about, I don't know, specific Kubernetes objects, for example, nodes, for example, pods, deployment service, whatever, you use a get command, and you use get. Okay, sorry, my cluster didn't working correctly. Okay, I think we need to take short break because I'm having a difficulties with the technical stuff.
Okay, that's demo gods for you.
Yeah, that's.
How much time do you need to start from scratch?
I think about 5 minutes. So, okay, I can show you what's inside of our because formation. Okay, so basically while it deploys, I can answer some of the questions. So give me 1 minute. We can have a short 5 or 5 minutes break.
Good. Yeah, and you can play around in your environments if you like to. The ones that got the accounts. I checked that we had around 50 accounts delivered, so about half of you people, because I see more than 100 people joining and participating now. So about half of you have the AWS account. So don't mind any Bitcoins, please, but but you can play around, you know, and use the chance just to, you know, build some stuff and then destroy it afterwards, because the plan is that maybe an hour or two after the workshop ends, we'll be deleting all the resources in the accounts that we have now. I see that some people are even happy that we will have a break. Yeah, I think that theory part is usually, at least for me, that's the most exhausting part.
yeah, because every time when we do workshops on the prem, so we have for about 15 minutes of break, because yeah, a lot of information for the starters, and we need to do some kind of break for that. Okay, so my cluster.
Aivaras, we have some suggestions that, you know, if it's not a secret, maybe you would like to share what you're doing. Maybe somebody will learn a few things from that, because I'm sure you're just rebuilding everything from the scratch.
Yeah. Basically, what I have here, that my cluster stack was just stuck from the deployment, and I don't know why that happened, but I think because when I was creating from the Cloud9 environment, maybe it's logged out and didn't shut down our EC2 instance, and that's why it doesn't finish the deletion of the cluster, as I see. So basically, we'll just wait, or maybe I can just create.
I can always send you a new account.
No, everything is fine. Everything is fine. So yeah, okay. We're gonna deploy a by side one cluster. So yeah, so basically what you can do while we're waiting, I will open our environment. So basically I won't be able to show you what is done right now, but you can type your own commands. So first of all, this kubectl get nodes command, which defines as a short summary of our nodes that have been deployed. So basically about our worker nodes, will be a short command. So it will be a short information about our Kubernetes cluster. And if you want to get a little bit more and detailed information about each kind of our Kubernetes cluster resources or Kubernetes objects, you can use a kubectl describe and specify a Kubernetes object what you want to describe. For example, nodes. So I won't play hit enter because I can't show you anything because I don't have specified run our environment yet. So yeah, so you can play with it a little bit. In the meantime, I can answer all the questions that we have here, or we're having a break. Okay, so let's start answering our questions.
Yeah, I think you can take the questions in any case, as we'll be sending the Q&A transcript in the follow-up email. So if anybody will not hear that, they will see that in the email. So please go on.
So yeah, one of the question is what is the advantages of containerization when I should consider use them in my company. So basically, you can use containerization when you have a developer kind of stack, when they are starting to develop and build your applications inside of containers. So that's one kind of point. When you have some kind of third-party company that develops for you, and basically because containerization is like it's like a, I don't know, heavy topic, hard to and I don't know how to say it, but it is pretty common topic in these days programmers' life. So they will mostly deploy your application inside containers. So that's when you should consider going to containerization. So basically, if you have applications and you have monolith application and you want to rewrite it in some microservice manner, so you can use it. You can go to the containerization, and that's basically it. Okay, one more thing from the anonymous attendee. It said that I know the ECS but not Kubernetes. How steep is the learning curve? So basically it is quite steep because you need to learn all kind of things about Kubernetes when you're deploying your new application inside of Kubernetes, because what you have from each ECS, you have your prepared container images, yeah, but then you need to write this kind of configuration for the all kind of Kubernetes objects. So for example, if we're gonna open our Kubernetes dashboard, which we're gonna deploy in a few minutes, so you can see that there is a lot of information to know how to deploy your application inside of Kubernetes, because what you have from ECS, it is like this one line, because it is just a Docker container image, and you have a container port on which it exposes. So, and also the name. So everything else you need to learn and know about Kubernetes. So basically, when I started to learn Kubernetes, I have just basic knowledge of the containerization. So it was pretty difficult for me to do that. So, but if you take a small step, everything will be fine, I guess. Is it possible to have a security groups to limit access between the services inside of cluster or deployment? I don't know about security groups, but there is called network policies. If you're using Calico, it has this kind of network policies that you can use them to separate even your services to contact each other inside of your cluster or deployment, or even in the same namespace. You can just have policy-based access to each kind of resources. So I don't know about security groups to use that for that kind of purpose, but there is a Calico network policies to limit access. So yeah, I will check it and we'll gonna see. Okay.
One more question, or are we good to go further with the workshop?
No, we'll still have a time break.
Okay.
Sorry, yeah, it's saying that it's still deploying. So if we're gonna go back to the cloud formation, so yeah, we can talk about how it is done in EKS and with the EKS CTL, because it's based on the cloud formation stack. So if you open, for example, stacks, all of you guys have this kind of cloud formation stacks, and there is two of them because we created a Cloud9 environment, and by that we are working in it. And there is another which is called EKS CTL EKS workshop stack. So if we open it and we'll check our events, so we see that it does a lot of work and a lot of automation for us to do it. So yeah, basically it will create a different kind of subnets, NAT gateways. We're gonna edit row tables inside of our cluster. We're gonna have a control plane configured from the big scale inside of the managed services, and we're gonna have a lot of work to do by our hand if we need to do it by the hand, but because it's managed, so it is pretty simple. Okay, so I see that a lot of done work. It is done, I guess. Cannot see through this. Okay, it is still creating. So basically, the most time takes our network load balancers to be working. And if you remember in the slide, I can share it one more time, that we have in our control plane, we have a network load balancer working inside of it. Because when you're exposing a service from the, you're exposing service outside the internet, they will use a network load balancer or application load balancer just do that. So basically, network load balancer takes for 10 minutes, I guess, to deploy. So basically, the most time it will, because of network load balancer deployment, it takes some while. Still deploying. So yeah, so today, demo gods are not in with us.
There's a nice question about your opinion on using Terraform or CloudFormation, which is your preference choice.
We had a customer once that wanted to replicate everything inside of AWS through the different kind of regions. So yeah, if you're using Terraform, it is quite nice, but it is not so intuitive, I guess. And if you are using CloudFormation, for me, because I had some kind of experience with CloudFormation with different kind of clouds or automation. So for me, preferably it is Terraform. But CloudFormation, if you are doing just in Amazon, everything, CloudFormation, it is the main goal, I guess.
I also saw a nice question concerning the monitoring and alerting. Do you think CloudWatch is enough for that, like the native AWS service, or would you recommend using something more specific?
Yeah, I would like to recommend something specific, and it is Prometheus that we are using for us inside of our on-prem deployments. So you need to work on it because it is also open source tool and it has some kind of features and but yeah, it is basically the best tool to monitor everything inside of Kubernetes, where with everything inside of Kubernetes in the point of Kubernetes objects. So basically, we are using Prometheus and we're using Grafana as to represent this kind of data. Okay. Is it possible to SSH to created nodes? Right now, maybe not. Yeah, if you've seen in our EKS workshop.yaml, so this is the KMS key, which represents us our SSH key generated inside of an environment and placed to our EKS cluster. So basically, if you have a private key of this kind of KMS, which you, I guess, don't, so you won't be able to connect. But yeah, in the real-time deployments in your own accounts, because it's predefined, you can use an SSH to your created worker nodes to access and just maintain them, and it's reasonable to do that.
There's a question, if you could explain the concept of tokens while we are waiting for like the one that we'll use for dashboard.
So basically, tokens are auto-generated when you use in programming tokens. When you insert your credentials, username and password, you get a token that is valid for some kind of period of time. And you use that token to access this kind of a period of time. And after it ends, you need to one more time access, input your credentials, username and the password to regain that kind of token, and you'll be generated a new token for that kind of purpose to access it. And if you try to use some kind of, I don't know, REST API or something else with the authentication, then probably all the time you'll be using token, because when you connect one time, you want to periodically use a token to access these connections, but not to type your username and password. So basically the concept is like that.
And then remember, Aivaras, if you answered the question from Yuri, is it possible to have node group with minimum size of 0? Most probably then just to have them up and running only once you have some workload on that.
I don't know, but I don't think, because when you're using EKS, you're also paying for the management plane a little bit, but I don't think so. I can answer strictly, but I don't think so.
Okay, so then we'll just check that afterwards.
Yeah. Okay. Yeah, there's one good question from Laudus. It is possible to assign IAM role, and what would be the smallest level of that service or the pod? So yeah, if we open, we can go through the Kubernetes dashboard a little bit. It is a file that I borrowed from the official Kubernetes site. And if you see inside of deployment, we can go through all the deployment file that we don't need a little bit later. So we have a deployment, and inside of it, we have a label for that kind of deployment. We have our deployment's name, where we're gonna place it. We're gonna place it in the namespace and kube system namespace. And after that, we have a specification from whom we're gonna create our basically pods. This is the specification for the deployment. So we have one replica. We're gonna have a revision history limit of the deployments, and we have a template for our pods from whom we're gonna create our template. So if you look a little bit later, we have a service account Kubernetes dashboard. So basically, by the service account, we can specify an IAM role for the pod. Oh, God damn it. Yes, we have up and running our cluster. So so basically for the pod, you can specify your IAM role. But I don't suggest you do that, because everything inside of Kubernetes clusters should be done through the role-based authentication. I'm not quite sure, but I think I've seen that you can have an IAM roles same IAM roles for the Kubernetes cluster through some kind of add-on that will act as a airbag authentication model. So, because my cluster is up and running, so we can proceed to our workshop. So as I said previously, we can, firstly, we can check if we have some kind of pods deployed, nodes. So we'll use for that kind of purpose kubectl get command, and we're gonna specify what kind of Kubernetes object do we want to get. So we specify nodes, and yet we see that we have three kind of nodes deployed. So if we open our EKS workshop.yaml and we set it to desired capacity, and yet we have three working nodes deployed. So basically, when you use kubectl get, you'll get a short summary of information. And if you use kubectl describe nodes, you'll have a lot of information about each of these kind of resources, about these kind of Kubernetes objects. So, but if you want to describe just a single one of them, you can just copy it and just paste it. And you can have described just one Kubernetes node. So there, let's have there you'll have a lot of information. You can have a name, you can have a labels assigned to that kind of node, you can have a creation time creation timestamp when it was created. We have an address, we have a capacity, and a lot of more information. So yeah, so basically we ensure that our Kubernetes cluster is up and running, and you should see in the same thing that I seen, EKS cluster in our island region, it is ready. So now let's deploy our first add-on to the Kubernetes cluster, which is called Kubernetes Dashboard. So if you've done this, okay, if following by the lab guide, if not, I can go shortly through our Kubernetes Dashboard file and see what we have here. So yeah, we have a secret. So basically it is a little bit of advanced topic. So when you need to store inside of Kubernetes some kind of secret data, if it's certificates, passwords, I don't know, login strings or something else, you'll use secret as a Kubernetes object. So yeah, next one, we have a service account. So basically, when you are using user accounts, there you can assign a service account, which is some kind of permissions to what your pods can do inside with the Kubernetes API. So basically, you specify for the pods that you'll have a service account, and with that kind of service account, you can do additional work with the Kubernetes and ask for them for additional kind of resources inside. Next one, we have a role. So basically it is role-based authentication models thing, and you'll have different kind of permissions when to specify what can you do and what can you interact inside of a Kubernetes cluster. So for example, to create a secret, to update secrets inside of this kind of resources, and etc., etc. Also, it is a little bit advanced topic, so let's move forward. We have a role binding, which is when you have your service account and you have your role, you need to bind them, that your service account will have this kind of role. So you bind them, and your service account has a permissions to do additional work with your Kubernetes object. And yet we have a deployment, yeah? So as we mentioned, we have a name, we have of the deployment, we have a namespace where we're gonna deploy our deployment and all the pods inside of it. Kube system, it is a generic namespace where we deploy all our management information basically. And we have a specification of our deployment, yeah? We'll say that we have just the one replica of the pods inside of it. We're gonna have a revision and history limit for this kind of deployment if we want to roll back our deployment. And yet we have a template for our pods by whom we're gonna create our pods. So yeah, we have metadata, which is we have a labels assigned to our pods, which will be these kind of labels. It is a key and the value. And we have a specification. So specification for all our pods that we're gonna create for this kind of deployment. Yeah, we have a container name, we have an image. It is a Docker image from where we're gonna deploy our container. We have a parts which will be binded to that kind of container. And also we have additional arguments. It is also advanced topic. We can pass to our container additional arguments when it is deploying. And we have a wall mount. So basically wall mounts, it is like mounts of network share. So we'll mount some network share to some kind of path inside of our containers. So for example, there we're gonna mount inside of our container under the certs directory, we're gonna mount our Kubernetes Dashboard certificates. From where we're gonna take our secrets that we've seen previously. Yeah. And we have our liveness product. So remember from the slides that we have had 3 different kind of health checks to the containers. So yet there we're gonna have a HTTP GET health checks. So we're gonna check our root path of the container and gonna check on the 8443 port. And there's additional information on how many of time we'll have a delay, etc., etc. And also we'll specify volumes from where we should take our information to mount them right here. And yet we have assigned our service account name for our Kubernetes pods. And because we need to expose our Kubernetes dashboard to our cluster, inside of cluster, we have a service. So you remember that I said that our service, it is like a load balancer. It has a source port, destination port, and it has a selector, yeah? So if you had attention, so by this selector, we ensure that when everything that connects to this kind of service, and it needs to be load balanced, or its traffic needs to be load balanced, everything that goes to port 443 will be load balanced to the port 8443, and to those pods who has this kind of label. So basically, it is a label selector, yeah? So if we go a little bit upper, in the pods template, pods creation template, we specify that every pod that we're gonna create will have a same label. So by that, how our service will know how to traffic all the, how to load balance our traffic. So, okay, we can now create our deployment, our Kubernetes dashboard. So what we're gonna use apply command. So basically it is to create, when you're creating some kind of resources and you're updating them, you'll use the apply. -f, we seen with EKSCTL, we'll specify from what kind of file we want to take a configuration for that deployment, place it, and we see that we created all these kind of resources. One more thing, when you are writing your own YAML files, remember that hierarchical order, how you specify each kind of Kubernetes object, it is really, really strict, because if you create a deployment before, for example, service account or the role, it won't be deployed because it doesn't have a service account yet created. So hierarchical order to create this kind of resources, it's really, really needy. Okay, next thing, we need support forward to our Kubernetes dashboard, because we didn't expose Kubernetes dashboard inside to the outside of the world. Yeah, we just exposed inside of the cluster. So next thing, what we're going to use a kubectl proxy, which will makes us just port forward to our specific kind of service. kubectl is capable of that. So we're gonna create a port forward to access our Kubernetes there. So what we want to already assign that we're gonna use a port, a local port, and we're gonna listen at this kind of port on our every single IP address inside of our Cloud9 environment. And one more thing, we want to disable a filter, because with filter enabled, it won't just show us anything. Let's press enter. We see that have serving for our port forwarding enabled. And now what we can do, we can access our Kubernetes dashboard in the Cloud9 environment by navigating to the tools, preview running applications. So basically what we have here, we have a cluster of our EKS API endpoint. And now I will use also a cheat sheet just to copy it URL, what we need to paste it for that kind of API endpoint, because it's pretty long. So yeah, we can press it and we see our Kubernetes GUI. Yeah, we'll use it a token. If you want a bigger screen, you can click this button here next to the browser, where we'll open it in the new window, in the new browser window. Yeah. And last thing, what we need to do, we need to get access tokens to Kubernetes dashboard. So basically, we're gonna get a token from the cluster. Let's copy it. As we've seen that from the status token and quote, we start with the K8S and we copy it until the end. We choose a token, enter our token. Okay, authentication is not right. Yeah. So basically, my workshop guides are not really with me today. Okay, so I won't be able to show you this, I guess. Okay, that's really, really weird, because yesterday I tried it at least 50 times and everything worked fine. So please write in the chat, is everyone managed to connect to the Kubernetes dashboard who are going through the workshop with me?
Aivaras, there are some suggestions just to give it a try once again. I don't know why. For ours, it took several times to work.
Okay. Now still authentication failed. So yeah, maybe we have some left problem. Oh, sorry, I know why. Who says why I'm getting this kind of authentication? I will get, I don't know, 1 hour of the free containerization lecture. I don't know.
You should be careful. I see already ideas that
typing some answers.
Yeah, I see in the chat a lot of you should check it out.
Okay, where's the chat? Okay, chat. As we see here.
That the VFS connection doesn't exist. Wrong name, cluster name.
Okay, who said the wrong cluster name?
The first one is Thomas Baltushis, I think.
Okay, Tommy, please.
Oh, no.
So who was the first one that said about wrong cluster name, please write me an email, and I promise I will get you a 1 hour Q&A about containerization.
Okay, I'll look through the chat and reach out to the people.
Okay, thank you. So yeah, because we already created another one cluster, and we still having a previous cluster in its stuck state, so I copied the wrong token inside of it. Okay, or maybe it was wrong, or I just didn't copy it. Okay. Oh, sorry. Oh, come on. So I think not. Okay, so we're still having troubles with connecting it, but yeah, basically what I was searching that, yeah, I had a wrong cluster name for that kind of purpose. So, okay, so please by yourself review what we have there. There should be a just graphical interface for the Kubernetes cluster. There you can manage all kind of different objects for your cluster. Okay, I will try it one more time, and we'll see what we have here. Because one more time I misspelled. No data available. Yeah, still having problems with that. So yeah, okay, so you can manage it by yourself to just go through the.
At least from the chat, I guess that it works for most of the people. So I guess.
So yeah, maybe I have some kind of wrong configurations, because we can go back to cluster and see the. Yeah, we still have a delete fail cluster. So all cluster failed to delete. So maybe we have some leftovers or cached information about it. So okay, so let's hop to next thing. What we're gonna have here, we're gonna have deployed our example microservices. So basically what we're going to have, we'll have a simple, really simple microservice architecture where we have a one front end and have a two backends, and these kind of front end and back end are written in the different kind of languages, and also the front end is written in different kind of language, but they each other interact with through the HTTP request and through the APIs. So basically they don't need to interact through anything else. So they know how to interact and know where to interact. So let's hop in to deploy our example microservice. So first of all, what we want to do, it is to review our Node.js folder and firstly our deployment.yaml file. Yeah. So what we have here, we have a just simple deployment. As you previously seen that in Kubernetes Dashboard, we have all kind of Kubernetes objects in the one file. Yeah. And right now we have a separate file. So this is basically your thing to choose. Do you want to add it to the one file, or do you want to separate it through different kind of files, this kind of different Kubernetes objects? So yeah, so what we have a deployment, we have a deployment name, we have a labels for that kind of deployment. What we see there that we're gonna deploy in the namespace default. So each of you guys have a default namespace, so there will be deploying. And we have a specification for our deployment. So we have one replica, what you see in the previous Kubernetes example. We have a application Node.js match label, which will gonna have our deployment. And we're gonna have one more thing. We're gonna rolling update strategy. What does it mean? That it does mean that our containers, when we have a new deployment, they will be updated in the rolling update manner. About that in the, I don't know, in the advanced topic. And yeah, and we have a template. So it is basically the template, as we've seen in the previous example, that we have a template for our pods. So our pods will have an app Node.js labels, and we specify our containers. So basically, this simplest deployment YAML file that we can have. Yeah, we can just leave the strategy, updating strategy outside of them, and that's it. This is the simplest deployment that we can have. So we have images and its name and what kind of part we want to expose. Okay, so yeah, we can review our service YAML file. So by this service, you remember that we're gonna expose our application inside of the Kubernetes cluster. So we have our service names. By this name, we're gonna interact with our service inside the cluster through the DNS. We have a selector for this kind of service. And we have protocol and source and destination ports. So yeah, now we can create our application first. So let's create. Once again, we're gonna use a kubectl apply -f, EKS and Node.js. And notice that we are specifying just a folder because everything inside of that folder goes recursively and and Kubernetes will try to create these kind of files that we store in that Node.js folder. So what we want now, ensure that our deployments are up and running. So we want to get our deployments, yeah. And we see that our deployment is up and running. And we're gonna ensure that our service works also correctly and it was deployed correctly. And we see that our Node.js service is deployed and running. So yeah, there is another one service which is basically a default Kubernetes service that provides us communication with a Kubernetes API server through the service. If you need, for example, from Node.js to access a Kubernetes API server, then you can use a service name Kubernetes to access. So basically, that's it. That's for what it is used. Okay. Next, let's deploy our Crystal application, which is pretty the same as our Node.js application. It also have basically this very, very similar deployment, just the names and labels are different. So let's create. So how to create? Once again, we're gonna use kubectl apply -f. And we'll specify once again our EKS Crystal folder for that. Press it, and yet we have our deployment and service created. So to ensure that, we're also using the kubectl get command. And now we can use short terms for the deployment and service to ensure that we have up and running deployments in the service. We can use for deployment deploy and for the service comma and SVC. And yet we see in the one kind of command about our deployment and the service. And see that our Crystal service and Kubernetes, it is up and running services, yeah. And last thing, what we want to do, firstly, we want to deploy our front-end application, and after that, we're gonna review it, how it differs from our Node.js application and Crystal application. So, yeah, Same thing for the applications, for all the applications. kubectl apply -f EKS frontend. We specify directory. We press enter, and we see that our deployment and service was successfully created. So we can get deployment and service also to ensure. Okay, we see that our front end is still not up to date. Mine endpoint, it's front end, it's not. Yeah, and now it is ready. So okay, so let's review our deployment and service file of the front end application. So let's see what we have here. We have the same information. It is deployment, name, labels, where to deploy our application in namespace, what kind of, the same rolling update strategy, almost the same template, just the names and the labels are different for the pods creation. And we have a specification. What we have here, we have one kind of additional part where we specify env. So env, it stands for environment variable inside of our containers, inside our pods. So what we have here, we have that each of our containers that we will create of front-end application will have inside of environment variable called crystal URL, and it will be this kind of value of it. What do we have here? We have a URL. If you remember that I said that each of the service inside of cluster is exposed through the DNS name. So we have our services name, we have our namespace to which we're gonna create. We have that it is a service, and we have a default cluster local name for the cluster, and the path to our application. So it is basically placed in the crystal application. And we have the same for the Node.js. We have a service, and we have a default namespace where we placed our service. We have Kubernetes object short name for the service, SVC, and we have our service. So basically it is a full path and FQDN to our service inside of Kubernetes cluster. And if we open our front end, what is different there, that we have additional specification called type. So what does it mean? It does mean that we're gonna have an external load balancer, and we're gonna have exposed our service through the load balancer. And because we are using AWS, it is defaultly configured that through the network load balancer, we're gonna have an access to the outside of the world. We'll have access inside of it, inside our service from the outside of the world, and through this kind of DNS name. So yeah, and if you don't specify your type inside of your services, it will have a cluster IP. If you see in here, so it is basically the cluster IP. It is basically exposure of your application inside of your Kubernetes cluster. It won't go to the outside of the world. So what we can do right now, we can copy our external IP or FQDN and paste it to our web browser. And if the workshop guide will be merciful for me, it should work. Oh, God damn it, at last. So yeah, we see that our application is working. And what we see there, that we prepared to auto-scale our application, but right now, because we have just for the one pod of each kind of our endpoints, for the front end, for the Node.js application, and for the Crystal, then our requests are not load balanced through these kind of pods. So let's try it to load balance it, to increase our replica set. Yeah. So first of all, there is three kind of commands and ways how to increase your replica count. So first one, let's say we want to scale our deployment Node.js. So we will use it just scale command. We specify what kind of Kubernetes object we want to scale. So we want to scale our deployment, not a pod, and we want scale our Node.js deployment, and we specify with how many of replicas. So let's say 3 replicas. And it says that it is scaled. So let's ensure that once again with the kubectl get deploy and svc, deploy comma svc, and we're gonna get our deployment. And we see that we're already having ready 3 from 3 pods, and all of the pods are up to date and available. If we get our pods, we can do that also. We can use the pods or the PO just to ensure that. And what we see that our Node.js application has 3 pods running. Yeah, it has Node.js, Node.js, Node.js. So basically what we have here, because we had 1 pod already running, so when we scaled, it additionally scaled our pods by the template defined in the deployment. So if we go back to our example application, so we see that our Node.js application right now, every single request that goes inside of service, it is load balanced through these 3 kind of pods. So let's do the same for our Crystal application, but in the different kind of manner. So what we can do also when we use kubectl, we can edit our resources inside of the cluster. So basically you can use kubectl edit, specify a deployment. You specify that you want to edit Kubernetes object deployment, and you specify that you want to edit specific deployment called Node.js. Yeah, and yet you'll be opened with the VI, with the text editor of your terminal, and we search for the replicas. Okay, we see that we have 3 replicas, so we opened Node.js. So let's do that with Crystal. Sorry. Yeah, so we open it. We can proceed, go to the top. We search for the replicas. We press the insert, backspace, and inserted number 3. Then we can press escape, colon, right Q, and we'll see that our deployment inside of the cluster, inside of the etcd, it is changed and it is edited. So if we check our pods, we'll see that our Crystal application now has 3 pods running. So if we go back to our provided URL of the backend of the exposed service, we see that all traffic that goes to our front end, and when front end asks for the service, everything, it is load balanced through these kind of 3 nodes of the Node.js, and everything load balanced for the Crystal, also through the 3 nodes of its own deployment. And the last thing about deployments, let's edit deployment inside of YAML file. So for me, it is best way because you have a latest state of the information of the configuration inside of Kubernetes in your own files, and you can just save it, do the backup of them, and in the case of the disaster recovery, you can just run it and you'll probably get a same state that you had previously. So, okay, let's open our EKS folder frontend, and let's open our deployment.yaml. So basically what we're gonna do, it's the same as in the first step and the second step, but just we're gonna edit our local file, which is a deployment.yaml frontend, and we'll have a latest state in the file and also in the Kubernetes cluster. So Ctrl+S for the save, and we can do just what we can do. We can do apply -f to specify a file, what kind of configuration we want to apply. We say that EKS frontend, and we want to use or the specific file or the whole directory of it. So what we have here, we have that our deployment was configured, and because we didn't change anything in the service, it simply didn't change it. So yeah, so if we one more time check our pods, and we can check deployments, so pod and deployment, depot and deploy, and we see that all of our applications are working in a high availability manner, and we have 3 pods of the Crystal, 3 pods of the front end, and 3 pods of the Node.js. And if we go back to our exposed service, we see that now our front end also, it is load balanced through these kind of pods. Every request goes through, it is load balanced through these pods. So, okay, so do we have any questions, or at least something was clear for you guys after some workshop God's mercy?
Yeah, just you can shoot the questions in the Q&A part. I see like a question from Lauras about cluster IP seen as the private subnet. Do you have it? It's like the last one.
Cluster IP and the private.
Yeah.
Okay,
in cluster IP, we see a private subnet. Where does it come from? Is it the same as VPC and IPs are used from it, or is it an internal cluster subnet and is not visible from outside?
Yeah, it's a pretty good question, because cluster IP, if you see, we can check in our VPC private cloud resources that we have a subnet a little bit different than our name. So yeah, we have this kind of IPs, or 192 starting Sidro, and 172, which is for a Docker. But when we are using, when we are using our services, so for example, kubectl get services, we see that we have 10.100 and etc. So basically, Kubernetes, it has their own internal IPs for that kind of usability, for internal cluster usage. Because when you are using in the cluster IP, it will just communicate inside of the cluster, but it will never go outside of it. When you're using load balancer, then you also have a cluster IP, but you can have exposed them through the load balancers. So basically what it does, it nats to this kind of IP address on the host and the whole magic begins with the Cto Proxy. So basically, cluster IPs are just internal, and if you deploy your on-premise infrastructure, these are managed things. And I guess when you deploy an EKS, I never tried, but you also could do to specify a CIDR for these kind of IPs. So I should check it out because I've seen, I guess, that you can use a different and separate IPs address to use for the cluster IPs. So yeah, that's really a good question.
Okay, I see no further questions at the moment.
I see one. I see the Alexei's. Which credentials were used when getting a token for the dashboard? Command AWS EKS get token. So basically, we get a admin token. We are using credentials for admin. When we are using AWS EKS get token, we'll get just the admin of all cluster token. So yeah, and we can, there is an alternative command, but if you remember, I showed you that you need to, I showed you in the Kubernetes dashboard that you need to create a specific kind of service account to create it, and for your roles, for your pods, but also you can create it as simple user account and attach that kind of role inside of Kubernetes. Then you can use it kubectl to get these kind of tokens, because they will be placed in kubectl get secrets.
I also see a very nice question about, have you had experience moving containers from one cloud to another and back? Any advice what should be double checked, or does it not matter at all from where to where? Any comments on that, Aivaras?
Yeah. Basically, when you are using different cloud providers, and if you are using Kubernetes, it doesn't matter how you, where you're gonna deploy Kubernetes, because it is the configuration of Kubernetes YAML files, it is always all the same. And basically 99% of the time it works every time. So yeah, if you're going from one cloud to another, what I suggest you to do, create one cluster and another, and if you test it out, everything in the one cloud and everything is working fine, then you could just kill it then another cloud and just switch your DNS records for that. So basically, I never did it, but we did it with EKS, well, not EKS, with the ECS, and it was pretty simple. Yeah, so basically the idea should be the same. So that's it. Okay, can we go further? Yeah, we still have some time.
Let's move.
Let's move forward. So okay, so right now, yeah, you've seen how to deploy, how to scale, and how to expose our application. As you remember, you can expose our applications through the service type load balancer, but also you can expose through the ingress, but we won't do it today. So next thing, what we're gonna try a Helm, which is a package manager for the Kubernetes. So basically what we're gonna do, we're gonna deploy the same kind of application with the high availability, with all kind of these parameters that we specified inside of our deployments and the service, just with the one command. And we will review how to do a rollback to the previous version of the configuration of this kind of application. It is really handy when you have Helm and you'll use charts when you go from the one environment, for example, from the dev to the prod. because you just specify just one parameter which is needed to be adapted to production, and you are already can deploy in production. So basically, it is really handy tool, because when you do it by your hands, it is always possibility of the human error. Yeah. So let's get back to EKS workshop, our environment. And first of all, let's make a cleanup that you say that everything was created earlier, and everything is working just from previous steps. So we see that our pods are terminating. It should be deleted quickly. So after it's deleting our resources, so please follow. You can copy it from also from the cheat sheet. We can also delete this kind of resources. We can use delete command, kubectl delete, or you can just simply under the make cleanup copy this kind of commands and paste it into the terminal. So basically, yeah, we see that we don't have a pods, we don't have a services, except one, which is a Kubernetes, yeah. And we can see that we don't have any deployment. Sorry, mistake. Yeah, we don't have any resource. So basically, as I mentioned, the Helm is Kubernetes applications packager, yeah. So if we open our EKS demo folder, and we see there we have a templates folder, and we have this kind of values file. So please open our templates file, and for example, let's open our deployment and service to see what we have here. So yet there we have same old files that we used on the previous example. For example, Crystal, or we can open just a front-end file for the deployment. But what we did, we just parameterized it. So basically, we created a parameters where we want to create these files. So basically, we put it parameters inside of replicas that we can manage this kind of global values of all kind of files. So basically, if you want to set up for all our deployments just replicas, we'll use it in this kind of manner, values.replicas. This will be a global thing. And for another thing, what we want to parameterize, it's our image, for example. But you can parameterize as much as possible and as much you need it. So basically, we parameterized our image to where we want to take our image and what kind of version. So as see in our image version, we also will be using a global parameter which will be called an version. And for our front-end image, we're gonna use a specific parameter which will be called a front-end image, where we specify our front-end applications image just for the front-end. Okay, so for the services, it is basically the same as we've seen in the previous example. But if you want to, you can also just use parameters, for example, to the type of load balancer use, and it is your, as a solution architecture, responsibility to define what kind of parameters you want to introduce to your Helm chart, yeah? How do you want to produce them? So if you open a values file, there we have a release wide, our project wide values, where we have for all kind of our applications just 3 replicas, and all our images will use a latest tag. So for the service-specific values, for the deployment-specific values, we specify that Node.js will have an image, and that kind of image will have this kind of form. So, okay, first of all, I will delete this because all of you guys should have the same. And what we want to do right now, we want to deploy our first Helm. So what we're gonna use a new command line tool, which is called a Helm. So first of all, we can just use a dry install, which will print our files how they should be deployed, but it won't deploy after a parameter is set in the place. So we can use Helm install -- debug. Also, you can open a cheat sheet and copy it. Yeah, there's debug -- dry run to dry run it. And we specify a name of our Helm chart. And we specify where is our Helm is placed. So our Helm is placed in the folder called EKS and EKS demo under EKS/EKS demo. And we just hit enter. Sorry, mistype once again. I think I'm getting a little bit tired. And yet we see how our configuration should be deployed to Kubernetes after all the parameters was set in place. If you remember, we have a Node.js example, and if we opened our Node.js YAML file, we see that for us, Helm puts values inside of our templates files of the YAML files. So yeah, let's say that we ensure that all the kind of the parameters are in place. We can now not just dry run it, but already install our Helms. Yeah. And by that, what we did just deleted our dry run and debug, and we see that our Helm install it is deployed. So what we can do, we can just already use kubectl get commands to ensure that all the deployments, pods, and services was deployed successfully. So get deploy pod and service, yeah, and svc. And yet we see that we have from the one single command deployed whole our application. So we have our deployments deployed, we have our pods, 3 of them for each kind of application, and we have our services deployed correctly. So if you copy an external IP, go back to our web browsers, it should take some time while our load balancers should create these kind of rules so we can interact with it. So after a few minutes, we can see that our application is accessing information, and we see that kind of same application as we see in the previous microservice example. Yeah. So, okay, let's see for a minute. Do we have any questions while our load balancer?
I see quite a few nice ones. For example, Andreas is asking, how would you configure your deployment to be applied through CI? For example, Jenkins. You would automate it with a shell script, for example?
Okay. Basically, there is 2 kind of ways. You can do it with a simple shell script, or you can use just underneath a Helm chart, and then you can use you can specify some kind of a configuration inside of values YAML files, also with the shell script. So you can, yeah, use one deployment and direct your configuration to the deployments, or you can use Jenkins to just interact with the Helm's charts and values files. Yeah. Okay, I see. Oh, yeah.
Do we have time for one more question?
I guess
it's a bit specific
yeah.
one. I usually hear that from the customers as well. What about painless database MySQL clusterization? Do you recommend using containers for DBs?
It is big concern going through the containerization and about databases inside of Kubernetes, because for my own experience, if you have a central database and you have it on the, you have really big database, for example, 20 plus gigs, I won't use it inside of Kubernetes, because I don't know, I don't think that it should be done, because it has a lot of resources needed to them to be run, and etc. One case that I seen when to use Kubernetes as a database engine underneath. So inside of Kubernetes, you use a database. When you have a big kind of database as it's central and it is on-prem, and you need some kind of transactional databases around them, and they are really simple, really not big, then you can use databases inside of Kubernetes. But you know, as we have a lot of engineers, so there is a lot of opinions about that. So for myself, I don't use Kubernetes databases inside of Kubernetes.
I could add to that, as we have had plenty of projects with Kubernetes, EKS, ECS services, and like basically all the discussions we had around databases, they all ended up in the idea that, you know, database is not something that you should like put into containers. And like, I guess it would be more of an exception if you do that, and most probably some places might hurt you in the future.
So okay, because I've seen that yeah, our load balancer started working and had updated configurations, so we can just proceed few more steps and we are done with the workshop, and we can go through the last hour theoretical part. So yeah, we've seen that our application is working, and we deployed it with one single touch of the command line, and we deployed it in a high availability manner. Yeah. So how to manage control these kind of different kind of deployments with the Helm, where all the niceness of the Helm comes from. So first of all, let's sorry. Let's try to upgrade our application. Yeah, let's open our values.yaml file, and for example, on the Node.js application image, Node.js in image, rewrite in the end code, so not existing. Yeah, press Ctrl S, and let's upgrade our application in this kind of manner, because it's usual when you create application, you specify some kind of different images or different kind of tags, and etc. Then you need to interact with the values of your configuration file. So now we need to upgrade our Helm charts. So Helm upgrade, that's quite convenient. And what we want to upgrade, because we had our Helm name workshop, so we say that we want to upgrade our workshop, and we specify from what kind of folder or from where we're gonna upgrade. So we'll specify that from the EKS and EKS demo. And yet we see that our release workshop, which is a Helm chart called workshop, has been upgraded, happy Helm. So, okay, what we need to check as all the times to check our services, pods, and deployments. And yet we see what we have there. We have an image pullback error off. So that was on purpose, not like an EKS cluster creation on the earlier of the workshop. So yeah, what we changed in the Helm, we changed that our Node.js application would take a non-existent image and try to deploy it. And our Kubernetes, our Helm, it deployed it, but our Kubernetes says that, sorry dudes, we cannot run this kind of pods because we still cannot pull our image of this Docker Hub, for example. So yet what we see in the deployment stage, so we see that we have still 3 from 3 ready containers, and we have just the one up-to-date container. What does it mean? It means that it updated deployment, but because we specified in the deployment that one by one, it should create pods and kill the old ones, so it cannot create new ones. So from this point, what we want to do, we want to perform a rollback, yeah? So the previous Helm version, and to have a stable, early working Helm version of our application. So to do that, we can check our Helm status. So we can get that we have right now revision 2, and we can also get a history of our workshop, how it was deployed in the time of manner. So we use a history command and specify for what kind of a chart we want to use to see our history. So use a workshop. And we see that we had 2 revisions because we 2 times deployed our, and when we need to perform a rollback, we need to use a rollback revision, or rollback command line to roll back to the previous revision and specifying this revision's number. So Helm rollback rollback. We specify what kind of chart we want to roll back. Workshop, and we specify that we want to roll back to the first revision that we had. And we see that rollback was successful. If we try to see a history one more time, we see that our Helm deployments was performed 3 times. So basically, first when we installed, when we upgraded, and when we rolled. So if we check our resources, we see that everything went back to the normal. We see our pods all running, and everything it is still working as it should. And that's how you can roll back to your previous version if you have some bug or something else inside of your Helms. So, okay, that was it from the workshop. Thanks, guys, for listening me on the workshop. Sorry for the all kind of problems that we have, but you never know. And one more thing, 2 more things, I guess. We need to make a cleanup. So previously I showed you how to make a cleanup, and now we need to deploy our, uninstall our workshop, and after that we'll have a brief, short 2 slides about our AWS containerization cost and effectiveness. So to uninstall our Helm, we just use Helm uninstall, and we specify what kind of chart we want to uninstall and press enter. And we see that our release uninstalled, and we see that our pods are terminated. And last thing, please delete our EKS cluster. So EKSCTL delete cluster -- name. We can copy it from the cheat sheet, which will be a little bit simpler. It is last command of today, and press enter, and we're gonna delete them. Okay, cannot delete security. As always, I have some workshop guards not in my side. Okay, so last topic, AWS containerization code. So let's talk about AWS cost and effective usages of specifically on the container infrastructure, because I've seen not so few of them over the time. So I see many times in the different infrastructures that instances running containers are underutilized. So what I mean that loads through the cluster nodes are not even. One of them working really hardly, and another is doing simply nothing. Yet there is another problem. When we need to deploy a new container, for example, which requires a 1 GB of RAM, then we have in our cluster, we have, for example, 800 megabytes in the one host, in the one Kubernetes worker, and 600 in the another host. In total, we have this kind of requirements, one kind of a gigabyte of RAM. But in one host, we didn't have it. So for that kind of purpose, we need to deploy a new instance. For example, it will consist of the 4 GB of RAM, and inside of them will be running a one just simple pod, yeah? And in total, we have 3 resources of the 3.5 GB of RAM. So it will be a pain in the ass because won't be able, we don't use these kind of resources, but we are already paying for them. So it is not good. So for one of those problems, if you need to deploy, for example, another instance, you can also use Kubernetes add-ons for this kind of things that is called a cluster autoscaler. But on the AWS, you'll still be using static autoscaling. What does it mean? That will scale statically your instance. For example, if you had this second explanation that we had to run just one instance for the one pod, the problem will still persist. So basically, what you need to decrease your counts, yeah, decrease your cost on containerization, because each of those ineffective resources uses cost you a lot of money. So you can use a EC2 on spot instance, but as you know, the problem about inefficient resources that persist and does require a lot of manual configuration, setup, and maintenance. To do that, to just simply run your EC2 on spot instances, because you can automate it, yeah, but it's pretty hard. I tried it for myself, but it's pretty hard, and you can do a better work besides of that. So after some while, I found out about a spotins and specific tool, which is called Ocean. So this product really ensures that your EKS cluster will automatically run on the optimal blend of the spot instances or some kind of a saving plans and reserved instances. Also, you can run it on the on-demand instances if you're required to. And you can use most suitable instance type that you will meet your container requirement. So next thing, what it has really nice feature called dynamic autoscaler. So it ensures that all the pods have resources to run on, and basically selects the most suitable your instance type that will meet your container requirements and can be deployed on. So if you on the natively EKS, you have a static, for example, auto-scaling group, and you statically can assure what kind of instance type you can deploy. With the spot-ins auto-scaling, you can use a different kind of flavors to do that, and you'll be decreased your cost dramatically. So also auto-scaler will scale up on new instances in the cases when you need them, and your infrastructure will be overutilized, and will decrease them if your containers won't need them anymore, and then your containers will be reallocated through those kind of instances. It also has really good advanced cost analysis, with which I tried, and it's pretty cool because you can specify for your EKS cluster what kind of application do you want to have advanced look at, and you'll get cost per your application pods or even storage capacity inside of the pods. So for all kind of resources, you have detailed information on how many of course you have from specific kind of application. And one more challenging task of managing containerized clusters is estimating your pod's resources requirements in the terms of vCPU and memory. So if you guys ever tried to specify this kind of vCPU or RAM for needed for containers, it is really pain in the ass, because if you have it specific kind of, you specify those kind of resources inside of a development, doesn't meet, and when you just take those resources and go to, for example, production environment, it can be different than in the. So yeah, if you're using EKS, if you are planning to use EKS, you should try a spot-in solution, because one more thing, they can save up 90% of the infrastructure costs, because of they are using they can use on the spot instances. And at first I was a little bit skeptical about that, because this is a lot of percents. I guess 90% of infrastructure costs, that's a lot. But I tried it. I was happily, but I can't say how many of percents we saved, because we're just using it for about 2 or 3 weeks. So I cannot say, but they have a lot of cases written in their page. So you can read it, and they are really, really awesome, have really awesome product. So that's all from me, I guess. Julius, do you have say anything? We can.
Yeah, I guess we can wrap things up. You know, we spent 2.5 hours. I guess everybody's looking forward to their supper. I just wanted to add about spot-ins. As yeah, we had a number of customers using that, and that I'm very happy with it. Just have in mind that the cost of the platform is 20% of what you're saving, which is, you know, also quite nice, I would say, from the perspective that you're only paying for stuff if you're saving money. And up to 20 EC2 instances, the platform is for free. So for most cases, especially not too big environments and clients, you can even have it running for free. And then I would say a lot of people are using that just to, and then, you know, it can work with EKS, ECS, or even your own Kubernetes cluster. But to sum it up, hopefully you had a nice time. Thanks a lot, Aivaras. Even with the demo gods not on your side, you managed to go through the whole workshop, which is really not very easy task if anybody of you did something like a live demo. And you know, just before we go, I have one small question, one small request from our side. We have like the last poll for you to say how happy are you with the workshop. So please just let us know how it went for you, and thank you very much for joining, and you'll be getting the follow-up information with the recording, the Q&A transcript, and everything else. Okay, I see what's coming in. I don't know if anybody noticed that I've seen like the list of people joining, like going down like one by one, which is quite natural, I think, as it's already getting close to later evening. So, but we still have more than 60 people that made it to the end. So congrats, and thank you very much for your time. Okay, I'm ending the poll, sharing the results. Aivaras, I think you'll be happy with that. And thanks for your feedback. Thanks for your time. Let's keep in touch. And you know, my suggestion would be if you liked the things you saw today, so try containerization, try EKS or any of our AWS managed services that can work with that in conjunction, and build nice stuff, especially as we have now plenty of time at home to do that. Okay, so bye everybody. I'm ending the meeting now, and let's keep in touch.
Bye.